Let's cover a couple of quick number theory proofs. We'll start with a couple of definitions. One, an even number is of the form n equals 2 times m, where n and m are just integers, like 1, 2, 8, 7, 15, negative 34, whatever. So the number 8 is even because it is 2 times 4. The number 34 is even because it is 2 times 17. And then the second definition, an odd number is of the form n equals 2m plus 1. So the number 35 is odd because it is 2 times 17 plus 1. The number 9 is odd because it is 2 times 4 plus 1. So the claim here is that, 1, if a number is even, then its square will be even. And 2, if a number is odd, its square will also be odd. And so we'll just directly prove the first one. N equals 2, let's call it P, just another letter we can use. Don't be distracted by that. And so what we're going to do, we're going to square both sides here. N squared equals 2p squared. And just carrying out the algebra of this, 2p squared is the same as 2p times 2p. We'll just rearrange that a little bit. 2 times 2 times p times p. That is the commutative property. And then we can rewrite this a little more suggestively as 2 times p times p, right? And this here, this is of the form that n squared equals 2 times m, where m is, 2p squared here. Therefore, n squared is even if n is even. And similarly, we can do a direct proof on the second claim here. If a number is odd, its square will be odd. Okay, well, let's start with, let me put a little line here to separate our, ooh, that's not straight at all. Okay, so let's start with an odd number, n equals 2p plus 1. And in the exact same way as before, we will say n squared, right, equals 2p plus 1 squared. And, carrying out the algebra of this, so equals 2p plus 1 times 2p plus 1. And we can use methods such as, FOIL, first, outer, inner, last to solve this. So we will get 2p times 2p plus 2p times 1 plus 1 times 2p plus 1 times 1, and cleaning that up a little bit, that's going to be 4p squared plus 4p plus 1. Now we can rewrite this a little bit. We can pull out the 4 here and say that it equals 4p squared plus p plus 1, and write that just a little more suggestively. This equals 2 times 2 times p squared plus p plus 1. And notice this is also of the form n squared equals 2m, where m in this case is 2p squared plus p. Therefore, n squared is odd if n is odd. That's just a couple of quick what we call direct proofs in number theory.